In this video, we will continue to talk about project management. There are a couple subjects remain for this topic. The first one is the critical path method, which is something that we want to discuss today. And in a separate video, we will talk about the critical path method with 3 activity time estimates, as well as the time cost models. So what is critical path method? The path taking the longest time throughout the network of activity is called a critical path. The critical path basically provides a wide range of scheduling information that will be very useful in terms of managing the project. It can help you identify what activities are so-called critical activities and what are so-called non-critical activities. And for those non-critical activities, how much time can be delayed without affecting the progress of the project. Something like that. And you need to remember, for every single project, there might be multiple critical paths and they are all valid. And those critical paths can help you identify the critical activities. And once you are able to identify the critical activities, you know you cannot allow any delay on those, because so long as there's any delay on the critical activities, the entire project's progress will be delayed as well. And once you have a critical path, you can also determine what will be the project durations and what will be the minimum time required for you to finish the project. So it is very important for you to identify the critical path, because once you know that, you can identify which one can be shortened if you want to invest some money to improve the progress. So there are 4 different steps for you to identify the critical path. The first one is to identify each activity to be done and estimate how much time you will take for each of those activities. Then we want to determine the required sequence and construct the network diagram. So basically, we need to know which activity need to be done first and which one can come later, what will be the right sequence. Then, once you have the network, you can determine the critical path. And finally, you can calculate the early start time and the early finish time. So what will be the earliest time you need to work on this activity? And you can also calculate what will be the late start time and the late finish time. And what will be the latest time you can start this activity. Once you are able to calculate these two, you can calculate the slack time and know how much delay will be allowed for that particular activity.
In order to understand how critical path method works, we first want to use a network chart, so we will be able to understand how many activities that we will have and how much time it will take for each activity. We will also need to know which activity will need to be done after a certain activity are finished. So for this particular example, we have 4 activities. The first one is activity A, and it will take 1 unit of time. We also have activity B that will take 2 units of time. Activity C will take 1 unit of time, and activity D will take 3 units of time. Then, based on the table, we know activity B will need to be start after we finish activity A. So we want to use a direct arrow connect from A to B. Similarly, we cannot start to work on C until we finish A. So we want to connect A to C. Finally, we cannot start to work on activity D until we finish activity B and activity C. So we want to connect activity B to D as well as activity C to D. Now, based on the definition of the critical path, we know that critical path means the longest route from the start to finish. From this chart, we know A is our starting point and D is our finish point. So we will have 2 possible ways for us to start from A and end it in D. The first route will be from A to B, then from B to D. And we know the total time it will take us to finish A, B, and D will be 1 plus 2 plus 3. And the total time will be 6. This is from A to B to D. The second rule that we will have is from A to C, then C to D. And we know if we want to start from A to C to D, the total time will be 1 plus 1 plus 3, which is 5. And based on the definitions, the critical path will be from start to finish, also the longest route. So our critical path in this scenario will be A, B, D. And A, B, D is also what we call the critical activities. Now, in many real-world situations, it may not be the most efficient way for you to try all the possible routes from the start to finish because you simply have too many different activities. So we want to use a different approach. What we want to do is this. For each of those activities, first we want to define the early start time. Early start time basically tells us what will be the earliest time you can start these particular activities. And once you know the early start time, you can also find out when will be the earliest time you will be able to finish this activity. And we call that early end time. Similarly, we may want to know how much time you will be able to delay for this particular activity. So we want to find out what will be the latest start time. And when will be the latest time you need to finish this particular activity. And that will be the latest end time. So we want to use these 4 numbers to find out our critical path. So remember, earlier we have an example. We have activity A, the total time will be 1. Activity B, the total time will be 1 as well. Sorry, it will be 2. And activity C, the total time will be 1. And activity D, the total time will be 3. And B need to be done after A is finished. C will need to be done after A is finished. Similarly, we can start to work on D after we finish both B and C. Now, when you are trying to calculate the early start time and the early end time, we always want to start from the very first node. So in this case, we want to start from A. And we want to start from 0 because that's the beginning of the whole project. We always want to start from 0. The total duration will be 1, which means the early end time will be 1. Now, at this point, we want to work on the next node. The next node can be either B or C. Let's work on B first. We know for node B, we cannot start to work on B until we finish A. And the earliest time you will be able to finish A will be 1, which means the earliest time we can start to work on B will be 1. Duration will be 2, which means we will be able to finish B at time 3. Now, let's move on to node C. We know we need to work on C after we finish A. So the early start time will be 1, and the duration will be 1, which means the early end time will be 2. The very next node will be D. We know we can not work on D until we finish B and C. C can be done at time 2. B will be done at time 3. In other words, we will not be able to start to work on D until we finish B. So the earliest time we can start to work on D will be 3. Duration will be 3. It means that we will be able to finish D at time 6. Once you figure out the early start time and the early end time, the next thing you want to do is to figure out when will be the latest time you can finish this particular activity and when will be the latest time you need to start this particular activity. So in order to do that, we don't want to work on the first node here. We actually want to work on the very next node and work backward. So we know we need to finish the activity D at 6. That means the latest finish time will also need to be 6. If we need to finish this node at 6 and the duration will be 3, which means the latest start time will also need to be 3. Now, let's move on to C, because we know D, we will start to work on D after we finish C. Okay? So we know we need to start to work on D at time 3. That means we only need to finish C at time 3. If I want to finish C at time 3, that means I only need to start to work on C at time 2. Similarly, if I want to make sure that D can be started at time 3, that means B need to be finished at time 3. Duration is 2, so I need to start to work on B at time 1. Now, we need to focus on the very first node here. And remember, A will connect to B, A will also connect to C. So here, we know that we need to finish A in order to start to work on B and C. We will need to start to work on B at time 1, and we will need to start to work on C at time 2, which means we need to finish A at time 1. Otherwise, B will be delayed. Okay? And the duration for A1 is 1, so we need to start to work on A at time 0. If you still remember the previous slide, we know that the critical path will be A, B, and D. So let's take a look of A, B, and D. You probably will notice some things. That is, the early start time and the latest start time will be identical. For A, it will be 0 and 0. For B, it will be 1 and 1. For D, it will be 3 and 3. However, C is not our critical activities. And when the particular node is not our critical activity, you probably will notice something very interesting. That is, the early start time is different from the latest start time, which means this activity can be delayed for 1 unit of time without affecting the total project time. That's why we define the difference between the early start time and the latest start time as our slack time. That's the total time you will be able to delay for that particular activities. So whenever you are on the critical activities, that means those activities will not be able to be delayed without affecting the total project time. However, you can always delay those non-critical activities start time without affecting the final result. That's the definition of critical path method.
Now, let's try to visualize what happened using the same example. We know activity A, B, C will be so-called critical activities, and the duration of the project will be the sum of the duration of these three, so the total time will be 6. And activity D is not a critical activity, and we have the slack time greater than 0, which means if you want to move activity around a little bit, for example, move to here, it is okay because the project will not be delayed. However, if you try to delay activity D to a duration that is longer than the slack time, then the project will be delayed. However, if we look at the example on the right hand side, suppose there's a delay on the activity B because B is a critical activity. So as long as there's a delay, the total duration of the project will also be delayed. That's why it is very important for you to identify the critical activities, because those are the activities that cannot afford to be delayed. Let's go back to the step for you to calculate the critical path. We first said that you need to identify each activity and the duration of that. Then you want to construct a network based on the correct sequence. Third, you want to calculate what will be the longest route for you to go from the start to finish. Finally, you want to calculate the early start and the early finish, as well as the late start and the late finish. But in reality, you don't need to go through the third step, because if you have a very large very large project, it will be very difficult for you to find all the possible routes from the start to finish and calculate the durations. And also, once you are able to calculate the early start and the late start, you know which activities are critical activities already, because we know by definitions critical activity will be those with the slack time equal to 0. So the third step is kind of redundant and it's not very useful when you have a very large project. So how can we calculate the early start and early finish, as well as the late start and the late finish? Remember, when we are trying to calculate the early start and the early finish, we want to start from the very top node, your begin node, and work all the way down to the very last activity in your project. And we want to find out the early start time, then based on the duration of the activity, and calculate the early finish time. Then we want to use a backward pass, so it means that we want to start from the very last activities and find out what will be the latest finish time and backtrack to their latest start time. And we want to work on this backward until we reach the very first activity in your project. Then we can calculate the slack time, and we know the slack time will be the difference between the early start and the latest start. And if the slack time is equal to 0, we know it's a critical activity. However, if the slack time is not 0, it's not a critical activity. And this slide shows you the algorithm for the forward pass, and this slide shows you the algorithm for the backward pass. I don't want to read through it because I want to use the example to show you how it can be done.
In this example, we know there are 7 activities. And first we have activity A. The duration will be 21. We also have activity B. Duration will be 5. Activity C, let's put it down here. Duration will be 7. And activity D, let's put it here. Duration will be 2. And activity E, duration will be 5. Activity F, let me put it here. Duration will be 8. Finally, we have G. Duration will be 2. And let's try to connect those nodes. We know we cannot start to work on B until we finish A. So we have an arrow right here. And we cannot start to work on C after we finish A. So we have 1 down here. D will need to be started after we finish B. So we have B connect to D. And we cannot start to work on E until we finish C and D. So I have 1 here and 1 here. F can be start after we finish C and D. And G can be started after we finish E and F. So at this point, you probably will notice that this one is our starting point. This one is our finish node. So the next thing we want to do is to figure out the early start and the early finish time. Then we want to work on from the very last node to the very first one to figure out what will be the latest start time and the latest finish time. So let's start from the initial node. As I mentioned earlier, we always start from 0. Duration will be 21. It means that the earliest time we can finish activity A will be at time 21. Then we can work on B. We know A can be done at time 21. That means the earliest time we can start to work on B will be starting from 21. Duration will be 5. That means we will be able to finish everything by 26. Similarly, for C, we know A need to be done at 21. So the earliest time we will be able to start to work on C will be 21. Duration will be 7. So we will be able to finish that at time 28. We cannot start to work on D until we finish B. So the early time we can start will be 26. The time we can finish that will be 28. Then we need to work on node E. As you probably noticed, we need to finish C and D first before we can work on E. And the earliest time we can finish D will be 28. The earliest time we can finish C will be 28. Since they are identical, we know I can start to work on E at time 28. And duration will be 5, which means we will be able to finish that at time 33. Okay? How about F? We know for F need to be done after we finish C and finish D. C can be done in time 28, which means D can be done at time 28 as well. So the earliest start time for F will be 28. The earliest finish time will be 36 because the duration will be 8. Finally, we want to work on G. G will need to be started after we finish F and finish E. E can be done at time 33. F can be done at time 36, which means we cannot start to work on G until we reach 36. So the total time will be until 38. Okay? Once you have the early start and the early finish time, we can work on the late start and the late finish. So we always start from the finish time and backtrack to the late start time. So for G, we need to finish that at 38. Duration will be 2, which means we can start to work on that at time 36. Then we can backtrack to F. We know F need to be finished before we start to work on G, which means F need to be done at time 36. Duration will be A, which means that can be started at time 28. Similarly, the next node for E will be G, and since we need to start to work on G at 36, the latest time we need to finish E will be 36. That means the latest start time will be 28 as well. Then we can work on node D. We know D need to be finished before we start to work on F and before we start to work on E. E can be start at time 28. F can be start at time 28 as well. So the latest time we need to finish D will be 28. Duration will be 2, so the start time will be 26. For C need to be done before we start to work on E and before we start to work on F. There's a typo here. This is not 28. This is actually 36. Sorry about that. Let me erase it. Because we need to finish E at time 36. 36 subtract by 5, it will be 31. All right? Now, let's check C again. C need to be done before time 31 and before time 28. If we wait until time 31, we will not be able to start F at time 28. So actually, we need to make sure C can be done by time 28. Duration is 7, which means the start time will be 21. B need to be end before we start to work on D, so that will be 26. Duration will be 5. The early start time will be 21. Similarly, for A, we need to make sure we start to work, finish to work on A before time 21 here and time 21 here. So the latest finish time will be 21. The latest start time will be 0. Once you figure out the early start time and the late start time, we can try to identify all the nodes that has identical early start and the late start time. So that will be this particular node, and this one, and this one, and this one, this one, and this one. Then we try to identify the rule that can connect from the start node to the end node that can include the critical activities. So we have there are actually two possibilities. We can either do A, B, D, F, G. Or we can go from A, C, F, and G. So in this particular example, we have two critical paths, and both of them will tell you that the minimum time required for us to finish the project will be 28. And the only activity that allows a certain delay will be activity E. So we will be able to delay activity E by 3 units of time because the latency time, the slack time is actually equal to 3. So let's try to work on a different example. In this case, we have A, B, C, D, E, F, G. So again, we try to point out all the nodes. We know A has a duration of 9. B has the duration of 13. C has the duration of 4. D has the duration of 5. E, the duration is 1. F, duration is 5 again. Finally, we have G, duration is 3. And we know B cannot be started until we finish A. Also for C, we cannot start work on C until we finish A and B. And for D, we cannot start work on D until we finish B. For E, we need to finish C and D first. So we connect from C to E and D to E. Then we cannot start to work on F until we finish C, D, and G. So we need to work on C first, D first, and G before we work on F. Finally, for G, we need to finish E first. Then the next step, again, we need to figure out the early start time and the early finish time. Remember, we always want to start from the first node, and the initial node here will be A. How can you identify the initial node? We find out the node that without any connection connected to it. Okay, so A will be our starting point. We know we start from 0, and the early end time will be 9. Then we can move to B.
the early start time is 9, duration is 13, so we can finish B at time 22. Then we can work on C. We know we cannot start to work on C until we finish A and until we finish B. So we finish A at time 9 and we finish B at time 22, which means we cannot start to work on C until time 22. Duration will be 4, which means the earliest end time will be 26. Next, let's move on to D. We cannot start to work on D until we finish B. So our early start time will be 22, duration will be 5, so early end time will be 27. Then we can work on E. We know we cannot start to work on E until we finish C and until we finish D. And we can finish C at 26, we finish D at 27, which means we cannot start to work on E until time 27. Duration will be 1. Finally, we cannot work on G until we finish E, so we can only start to work on G at 28. Duration will be 3, which means the early end time will be 31. Finally, we cannot start to work on F until we finish C, D, and G. And C can be done in 26, D can be done in 27, G can be done at 31, which means we cannot start to work on F until time 31. And the early end time will be 31 plus 5, that will be 36. Once you figure out the early start time and the early end time, we want to work on the late start time and the late end time. Again, we want to start from the very last node. So we have 36 here, and we backtrack to the late start time. 36 subtract by 5 will be 31. Okay? Then we can work on node G. Okay? We know F cannot be start until we finish G. And we only need to start to work on F until 31, which means the latest end time for G will only need to be 31. 31 subtract by 3 will be 28. Similarly, we cannot start to work on G until we finish E, and we only need to finish E at time 28. So I have 28 here, 27 here. And we need to make sure we finish D before we start to work on F and before we start to work on E. And we need to start to work on E at 27, and we need to start to work on F at time 31, which means the latest time we need to finish D will be 27. So the latest start time will be 22. Similarly, for C, we know we need to make sure we finish C until before we start to work on F and before we start to work on E. And the earliest time we need to finish C in this case will be 27. So 27 subtract by 4, that will be 23. Okay? The next point we can work on will be B. We know B need to be done before D, and it need to be done before C. We only need to start to work on C until time 23, but we need to start to work on D at time 22, which means B will need to be ended before 22, and 22 subtract by 13, that will be 9, so the latest start time will be 9. Finally, we need to finish A before B and C. B need to be start at time 9, C need to be start from time 23. That means A need to be finished by time 9. So I have 0 right here. Once you figure out the early start time and the late start time, the next thing you want to identify will be the critical activities.
And in order for us to identify the critical activity, we want to find all nodes without any slack time. And when would be the case? You only need to identify all the possibility where the early start time is identical to the late start time. So we have A right here, we have B, we have D, we also have E, G, and F, because all the early start time and the late start time will be identical. Then you just need to connect the dot to find the critical path. So in this case, it will be A connected to B, B connect to D, D connect to E, E connect to G, G connect to F. So our critical path in this case will be A, B, D, E, G, and F. And that will be our final answer.